Let's take a look at Dijkstra's algorithm. Find the shortest path from vertex A to vertex E using Dijkstra's algorithm. So we're trying to go from A to E. And there are lots of paths that we can take. Which one's going to be the shortest? So Dijkstra's algorithm has a start at the ending, although you can also start at the beginning. That's kind of your choice. And so to get to E, I'm going to mark this vertex with the notation 0, E. That means that it's 0 weight or distance. Let's assume this is distance. I'm not quite sure what this is, but let's assume it's distance. 0 distance through E to get to E. Kind of silly, but that's true. Now, our first step is from E to get to every vertex we can. So we can go to D, and that would take 9. And so we would mark this with 9, and where did we go through to get to D? E. That would be interpreted as it's 9 distance through E to get to D. We can also get to F. So we're trying to go from E to every possible place. Now to get to F, it would take distance 10. And again, we would go from E to get there. Once we're done, we can cross off E. All right, next step, we look for the shortest distance that's not crossed off. Now, obviously, 0 is the shortest distance on here, but that's been crossed off. The next shortest is 9. Okay, so this is now the active vertex. So we go from there everywhere we can. We don't go backwards to a crossed off one. So from D, we can go to C, and we can go to F. So if we go to C, we've already gone 9. We're going 7 more. So to get to C would be a total of 9 plus 7 is 16. So we would mark C with 16, and what did we just pass through to get there? D, the active vertex. Going down to F, we are already at 9, plus 14 would be 23. So that would say 23, through D. However, that isn't as short of a distance as what we already have. And so we don't use that, we stick with what's already there. Okay, great. Next up, we cross off D. And we go to the next shortest distance on there. We have a 16, we have a 10. 10 is the shortest one. So F is now our active vertex. And we go from F everywhere we can. No, not there, not there. We can go to C, and we can go to G. I'm just going to do these in alphabetical order. So going to C, we're already at 10, plus 4, we could get up to 14. So we could have 14, passing through F there. Now this time that is better than what we have already. We have 16, D, but this says 14, it's lower. So we actually replace this with 14, F. Now what this means is although we can go 9 plus 7 to get to C, and that's 16, through D, but we can also go through F and go 10, oops, didn't mean to do that, where'd my highlighter go, there we go, 10 plus 4 is 14. Although maybe the lines look shorter, the actual distance for this path is 14 is a shorter distance from E to C. So it says 14 is the shortest distance, and you have to path find through F. And that completes F. Okay, what's the next active vertex? Oh wait, hold on, it doesn't complete F yet. We still have to go to G. Sorry, my bad. That is 10 plus 2 is 12. Passing through F. Okay, now we would cross off F, which is already done. Next shortest distance, 12. G is now our active vertex, and we repeat. From G, we can go to I and to H. Let's do the H first. 12 plus 1 is 13 to get to H, passing through G. And 12 plus 6 is 18 to get to I, passing through G, the active vertex. That completes G. What's the next active vertex? Let's see, we have 14, 18, 13. 13 is the active vertex. So H is the active vertex, at distance 13. Where can H go? H can go to A, to B, and to I. These are the three vertices that aren't already crossed off. So let's go in alphabetical order. 8 and 13 is 21 through H. Going up to B, we would have 13 plus 11 is 24 through the active vertex H. And then 13 plus 7 is 20. So this would be a 20 through the active H. But if we look at what we already have 18, which is better. So we don't use that. We stick with what's already there. Cross off H. What's the next shortest? I. Now I can go to C. Oh wait, hold on. What's the next shortest from 13 is 14. Sorry, C is the active vertex. I don't know why that keeps going to black when I have a... Anyway, there we go. That's the active vertex. Where can it go? It can go to B and to I. Going to B, 14 plus 8 is 22. That is better than the 24 we have. So that's crossed off, and it's 22, through C, the active vertex. Going to I, that's 14 plus 2 is 16. That is also better than the current 18. So now that's 16 going through C. Okay. That completes active vertex C. Now, what's left? We have three vertices that are not crossed out. 16, 21, and 22. The lowest is 16. This is now the active vertex. Where can it go? It can't go anywhere. Cross it off. Next, the shortest distance is A. At that being the active vertex, 21, it can go to B, plus 4 is 25. That's not as good as what's there. So we cross that off. And finally, B, there's nowhere to go. We cross that off. This is the picture that's left over from Dijkstra's algorithm. What this tells us is any vertex here, like C, we can see that it's a minimum 14 distance from our initial E, passing through F. F then passes to E. That is the path from E to C that'll give us the minimum 14. Now we wanted to get to A originally, so A says that it's 21. So here's our final answer. The minimum is 21. And what we would do is we'd go from A through H. From H we would go to G. From G we would go to F. From F we would go from E. And that's the path. That is the shortest path from the vertex A to the vertex E. Now, as a side note, if you lived in E, this would be a very nice map to have because you would know the shortest distance to get from E to anywhere in here. If you lived at A, you would want to start with A being 0, A, and go forwards so that not only when you were done would you have the distance from A to E, the minimum, which would be the same answer, but we would also know the distance to all the other cities in the neighborhood. So you can choose, if you're going from A to E, to start at E as 0 or start at A as 0. that's up to you. They would both give you the correct 21 minimum and the correct path. So go ahead and pause the video as you work on the problem on the right. What you should get is the minimum is 14 and the path is B, A, D, H. Specifically, we're going from B to H. B would be 14A. A would be 13D. Back to D. D would be 8H. And H, of course, is 0H, where we started. The rest of the vertices, 9D, 15B, 17E, and that completes the picture. All right, I hope this helps.